Hello, hi everyone. Welcome to the Student the Brand. This is our Shiva sir. Today we are going to discuss about light reflection and refraction chapter. Light reflection. Light reflection and refraction chapter. Okay. Light is a form of energy. Light is a form of energy which gives the sensation of sight. Yes or no? So light is a form of energy which gives the sensation of sight. Okay. Now here you are seeing I'm taking the plane mirror. Light reflection and refraction. Light reflection and refraction. Reflection and refraction. Light reflection and refraction. Okay. Right. Okay, light reflection and refraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. So I'm taking the plane mirror. So here is the plane mirror. Right. This is a plane mirror. The light which is incidenting on the surface is called incident ray. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. So I am taking this incident ray, reflected ray. I am taking this normal line, normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. Angle between incident ray and normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And this I am taking the undeviated line. So this line we are extending the light ray. Right? So that is undeviated line. Undeviated line. So the angle between reflected ray and undeviated line is called angle of deviation. So I am taking this angle of deviation. Angle of deviation. Angle of deviation. Okay. So angle between incident ray, normal line is called angle of incident. Angle between reflected ray, normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Angle of deviation. Okay. So linear angle normally loss of reflection. So this is the reflection of light. Reflection of light. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light. The bouncing back of the light from the reflecting surface. The bouncing back up from the reflecting surface is called reflection of light. Okay. So here are the terms: incident ray, reflected ray, normal line. So undeviated line. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and deviated line is called angle of deviation. Angle of deviation. Okay. So now you can observe here loss of reflection. So I'll discuss about loss of reflection. Loss of reflection. Loss of reflection. First one is incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. And coming to the second one, angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. I hope it is very clear to you all. So once again observe here, reflection of light. What is the reflection of light? Reflection of light is nothing but the bouncing back of the light from the reflecting surface. Here is the reflecting surface is the plane mirror where the reflection taking place, that is the reflecting surface. So here is the reflecting surface is plane mirror. Plane mirror is the reflecting surface. Plane mirror. Plane mirror. A highly polished, smooth, shining surface. A highly polished, smooth and shining surface is called a plane mirror. So one side is a reflecting surface, another side is silver coated. Okay, so reflection takes place only one side. So the bouncing back of the light from the reflecting surface is called reflection of light. So angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Okay, so incident ray, reflected ray, normal line lies in the same plane. So laws of reflection. Coming to laws of reflection, incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay, so this is about laws of reflection. And coming to the one more, so here you need to understand one thing. The linear angle is how much? 180 degrees. Linear angle is 180 degrees. Linear angle is 180 degrees. So that's why angle of incidence plus angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Sir, how you got 180 degrees? How you got 180 degrees? How you got 180 degrees? So the question is, you can observe here, angle of incidence plus angle of reflection plus angle of deviation. So these three angles are in the same on the same line. Okay, so are on the same line. Angle of incident, angle of reflection, angle of deviation. Total, if you take, so that is on linear angle. So that is 180 degrees. So that's why angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. I hope it is very clear to you all. Yes or no? So you got the point, right? Yes. Now you can observe here. So from laws of reflection, what we can take? So angle of incident is equal to angle of reflection. Can we take like that? So are you agree with me? Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Shall I take like this? And here from laws of reflection, angle of incident is equal to angle of reflection. We know this one. Okay, so we know this one. Now I am considering now here angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. 180 degrees. Okay, now angle of deviation equal to 180 minus 2 angle of incidence. Can I take like this? Shall I take like this? Is it clear to everyone? Is it clear to everyone? So, do you have any problem? Do you have any concerns? Do you have any doubt on this? I hope it is very clear to you all, because from laws of reflection, angle of incident is equal to angle of reflection, right? From that, so instead of angle of reflection, I am substituting angle of incidence, so that I can take angle of deviation equal to 180 minus 2 angle of incidence. So everything is clear, right? Yes. Now the angle of deviation is equal to angle of deviation is equal to 180 minus 2 angle of reflection. Shall I take like this also? Angle of deviation equal to 180 minus 2 angle of incidence. Okay, so this formula I wrote with the help of laws of reflection, right? So this formula I have written with the help of laws of reflection. The second formula also, so this is the first formula, coming to the first one, and this one is the second one. How did you get that, sir? Yes, from laws of reflection, angle of incident is equal to angle of reflection. So instead of angle of reflection, I substituted angle of incidence. So I got it. The angle of deviation equal to 180 minus 2 angle of incidence. So in the same format, angle of deviation equal to 180 minus, instead of angle of incidence, I wrote angle of reflection. So I got it. Angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear to you all. Do you have any concern? Do you have any doubt on this? So if you know, if you have, you can let me know. So if you don't have, no problem. I'll continue the next topic. Now, so I will explain about regular reflection and irregular reflection. So what is that, sir? Regular reflection and irregular. Yes. So now we'll explain about regular reflection and irregular reflection. Regular reflection and irregular reflection. So be ready for it. Okay. So regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Regular reflection. Coming to regular reflection. Regular reflection. Regular reflection. Regular reflection. So I'm taking the smooth surface. So this is smooth surface. So I'm taking the smooth surface. So incident light rays are parallel to each other. Incident light rays are parallel to each other. But reflector light rays are also parallel to each other. Incident light rays are parallel, then reflector light rays are also parallel to each other. Okay. So here I'm taking incident light rays. So these are the incident light rays. 1, 2, and 3. And last one is 4. Okay, so you can observe here. Okay, so we can take ray and we can take beam. So what is ray? Ray is nothing but, so light moves in the path of single ray, means single in one direction or one ray. Okay, so that is called ray, a single path. If you are taking many rays combined, then it is called beam. Okay, so then it is called beam. Okay, I hope it is very clear. Is it clear to you all? Yes. Now reflector light rays I'm taking here. These are the reflector light rays. Reflected light rays. Reflected light rays. Incident beam. So this is the incident beam. Incident beam. Incident beam. And this one is the reflected beam. Reflected beam. Reflected beam. Incident light rays are parallel to each other. Then reflector light rays are also parallel to each other. So okay, incident light rays are parallel. Then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Okay. Example for smooth surface. So I said plane mirror, and still water also. And still water also regular reflection takes place. Coming to irregular reflection. Irregular reflection. Irregular reflection. Irregular reflection. Irregular reflection takes place on rough surface. Irregular reflection takes place on rough surface. So I'm taking the surface like this. So incident light rays are parallel, but reflector light rays are not parallel to each other. Reflector light rays are not parallel to each other. So observe carefully here. So these are the incident light rays. These are the reflector light rays. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. So rough surface, if you rough surface example, you can take wall and you can take paper. Okay, so these are the examples for rough surface. Okay, so irregular reflection takes place on rough surface. I hope it is very clear. This is about regular reflection and coming to irregular reflection. Is it clear? Right. Now, Okay, so coming to the next topic is regular reflection, irregular reflection completed. So next one I will explain about image and object, image and object, image and object. So here one important point is, if it is related to incident light rays, that is object. If it is related to reflector light rays, that is image. Okay, so keep this one in mind. So I'm taking the plane mirror. So this is the plane mirror. I'm taking the plane mirror. So here is the object. This is the real object. Real object. Okay. How many light rays are required to form the image of the object? Minimum light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object, right? Yes, I'm taking 2 light rays. So you can observe here. One light ray I'm taking like this. So after that, this also one more light ray. So this will be reflected back like this. Reflected like this. And here also reflected. If you are extending these light rays, those reflector light rays are meeting at one point. Okay, so this is the virtual image. Real object and virtual image. Real object and virtual image. What is the difference? Real object means the point of intersection of incident light rays. Incident light rays are coming from this point, right? So that's why it is real object. Coming to the virtual image. Virtual image. The point of intersection of extended reflector light rays. This is the reflector light ray. This is the reflector light ray. We are extending those reflector light rays. Extended reflector light rays are meeting at one point. So their image is forming. That is a virtual image. So here from this point, light rays are coming. Incident light rays. Incident light rays are coming from this point. After incidenting, reflector light rays, we are extending the reflector light rays. After incidenting, so those light rays will move away from the principal axis. So we are extending the reflector light rays. This is the incident ray. I1, R1, I2, I2, R2. We are extending those incident light ray after reflecting. Okay. So we are extending those reflector light rays. These are the reflector light rays, right? So we are extending these reflector light rays. Extended reflector light rays are meeting at one point. Extended reflector light rays are meeting at one point. So their virtual image is forming. Virtual image and a real object. Okay, coming to the one more. So this is one object. So light rays are coming from this point. After reflection, those are meeting at one point here. Okay. So if you are extending these light rays, okay, so image is forming here. Image is forming here. So observe. So is it clear or not? Here, this is the real image, virtual object, virtual object. Sir, what is the difference between real object, virtual object? And what is the difference between virtual image and real image? Can you explain, sir? Yes, definitely I will explain. So the question is, difference between virtual image and real image, and virtual object and real object. Here you can observe this is a virtual image, right? Virtual image. Virtual image is nothing but we are extending the reflector light rays. Reflector light rays. We are extending the reflector light rays. Extended reflector light rays are meeting at one point. Means, so we are assuming that these extended reflector light rays are meeting at this point. So that point is called virtual image. That point is called virtual image. So here from this point directly light rays are coming. That's why it is a real object. Real object. Here you can observe. So these light rays are coming from the object after reflection. After reflection, light rays are meeting at one point. So their real image is forming. So reflector light rays are meeting directly. But here extended reflector light rays are meeting. Extended reflector light rays are meeting. That is a virtual image. Virtual image. Extended reflector light rays are meeting. That's why that is a virtual image. So reflector light rays. Here you can observe. Here you can observe. Okay. I hope it is very clear. So here, these are the incident light rays. These are also incident light rays. After incidenting, those are reflected back. So reflector light rays are meeting at one point. Reflector light rays, reflector light rays are meeting at one point. So this is the real image. Real image. So if you are extending the incident light rays, extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. Their virtual object will form. Virtual object will form. I hope it is very clear to you. Yes. Now we will go to the next topic. So that is okay. I will conclude this concept. Actually, conclusion is required. I will summarize this concept. You can observe here. So object and image, object is real, image is virtual. Object is virtual, image is real. Very simple. Object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. That's enough. So that is very, very important. I hope it is very clear. So what is reflection? The bouncing back of the light from the reflecting surface is called reflection of light. Okay. Next. So light ray is moving from denser to rarer. So in the rarer medium, it makes more than critical angle. Light ray is moving from, once again listen carefully, user ID 3, total internal reflection. You asked about total internal reflection, right? Light ray is moving from denser to rarer. Light ray is moving from, this is the rarer medium, denser medium. Light ray is moving from denser to rarer. So in the rarer medium, the refracted ray makes more than 90 degrees or more than critical angle, then it reflects back into the same medium, that is denser medium. So this phenomena is called total internal reflection. Total internal reflection. Is it clear? Right. I hope it is very clear to you. Next, I am going to the next topic. Plane mirror. Nature of the image formed by the plane mirror. Nature of the image formed by the plane mirror. Okay, na? So here you can observe. I am taking the plane mirror. Here. So principal axis. This is the incident ray. Okay. So this is the object. Object AB. So I said how many light rays? Minimum 2 light rays are required to form the image object. I'm taking like this, and here also. Okay, so now you can observe here. Chalo, chalo. Okay, done. Observe here. This is the object. Size of the object is AB. So this is the image. Size of the image is A dash B dash. Okay. So initially I explained one concept. Just before this concept, I explained one thing. That is, object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. First one. Coming to the second one is object distance is equal to image distance. So the distance between object to mirror is equal to object distance. The distance between image to mirror is called image distance. Object distance is equal to image distance. So point number 2. Coming to the point number 3, size of the object is equal to size of the image. That is nothing but height of the object is equal to height of the image. Height of the object is equal to height of the image. Coming to the fourth one, magnification is +1. Magnification is +1. Why? Image is always forms virtual, erect, and same size. Virtual, erect, and same size. That's why it is. And that's why it is. That's why it is. That's why it is. Magnification is +1. Height of the image by height of the object. Okay. So here virtual, erect, and same size. Virtual, erect, and same size. That's why we are taking magnification is +1. Magnification is +1. I hope it is very clear to you all, right? Yes. So once again, object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Size of the object is equal to size of the image, and size of the object is equal to size of the image. Object distance is equal to image distance, and also it forms magnification is +1. Virtual, erect, and same size. Virtual, erect, and same size. I hope it is very clear to you. So is it clear? Do you have any doubts? Okay, done. So next one. Curve, spherical mirrors. Spherical mirror. Okay. So what is meaning? What is the meaning of spherical mirror? What do you mean by spherical mirror? So spherical mirror is nothing but the mirror which is in the form of curved shape. The mirror which is in the form of curved shape is called spherical mirror. So I am taking like this, the mirror which is in the form of curved shape, that is called spherical mirror. Depends on reflection of light. Mirrors are divided into two types. One is concave mirror, another one is convex mirror. Sir, what is concave mirror and what is convex mirror? Concave mirror is nothing but, so the mirror whose reflection takes place inward. The mirror whose reflection takes place inward is called concave mirror. So I am taking here, this is a concave mirror. Reflection takes place inward. Reflection takes place inward. Okay. Reflection takes place inward is called concave mirror. Reflection takes place outward is called convex mirror. Right? Yes or no? Is it clear to you all? I hope it is very clear. Let's discuss. So here you can observe this is a concave mirror. Whenever light rays are incidenting on it, after reflection, those light rays are meeting at one point. So this is the concave mirror. Coming to the convex mirror. So convex mirror you can observe here. So what is convex mirror? Convex mirror is nothing but, so when incident light rays falls on it, so I am taking these are the incident light rays. After incidenting, so this will reflect, light rays will reflect. Okay, so because of reflection, so those light rays are moving away from it. Here, after reflection, light rays are moving towards the principal axis, but here, After reflection, light rays are moving away from the principal axis. That's why concave mirror is known as converging mirror, whereas convex mirror is known as diverging mirror. Diverging mirror, diverging mirror, diverging mirror, diverging mirror. Concave mirror, converging mirror, convex mirror, diverging mirror, convex mirror, diverging mirror, concave mirror, converging mirror. Concave mirror is known as converging mirror, whereas convex mirror is known as diverging mirrors. I hope you're clear with that. Next one, terms related to spherical mirror. Yeah. Terms related to spherical mirror. We are discussing terms related to spherical mirror. Shall we start? Just rock it. Okay, chalo. Let's start with terms related to spherical mirror. Spherical mirror. So I'm taking spherical mirror here. This is spherical mirror, and it is a part of the sphere. Actually, it is a part of the sphere. This is center of curvature. The center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. Midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The line joining of center of curvature and pole is called principal axis. Principal axis. Line joining of center of curvature and pole is called principal axis. First one is center of curvature. Second one is pole. Third one is principal axis. Principal axis. Principal axis. And coming to the fourth one, the distance between center of curvature to pole. The distance between center of curvature to pole is called radius of curvature. Radius of curvature. Coming to the fifth one, after reflection, light rays will meet at one point on the principal axis. After reflection, light rays are meeting at one point on the principal axis. Those are called focus. Principal focus. Simply we can say focus, or principal focus also we can say. Okay, so the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Denote with a small letter. Yeah, the distance between center of curvature to pole is called radius of curvature. The distance between focus to pole is called focal length. And width of the mirror is called aperture. Aperture. Center of curvature, pole, principal axis, radius of curvature, focal length and focus. And coming to the seventh one is aperture. Okay, so I hope it is very clear to you all. So once again we will discuss all the points. First one is center of curvature, second one is pole, third one is principal axis, and fourth one is radius of curvature, fifth one is focal length, sixth one is focus. Here the difference between capital F and small f. Capital F is focus, small f is focal length. and width of the mirror is called aperture. Width of the mirror is called aperture. I hope it is very clear to all. So is it clear? Yes. So next one we will discuss about ray rules. Ray rules of concave mirror and convex mirror we need to discuss. So are you ready? Students, are you ready for receiving? Yes, of course. Okay, so we'll discuss about ray rules and image formations. So be ready. Ray rules and image formations. Okay, so ray rules and image formations. Ray rules of concave mirror. Ray rules of concave mirror. So we'll discuss now. Concave mirror. First one. So here, so till now we discussed about full focus and central curvature, right? Full focus, central curvature. This is the pole, focus, and central curvature. Pole, focus, and central curvature. So if the light ray is coming from infinity, so I am taking light ray is coming from infinity. After reflection, it passes through focus, point number 1. And coming to the point number 2, light ray is passing through the focus. So pole, focus, and central curvature. Light ray is passing through focus. After reflection, it moves towards infinity. Light ray is passing through focus. After reflection, it moves towards infinity. Okay, so that is second one. Coming to the third one. Okay, so this is the pole, focus, central curvature, pole, focus, and central curvature. Light ray is passing through central curvature. Light ray is passing through central curvature. Okay, so it retraces its original path. Light ray is passing through central curvature after reflection, so it moves in the same direction. Okay, so coming to the fourth one. Here I am taking like this. Okay, so pole, focus, and central curvature. Pole, focus, and central curvature. Right? Yes. Now, light ray is incidenting at the pole. It reflects back into the same medium. As we know that on the plane mirror, okay, so if reflection takes place on the plane mirror, what happens? It reflects back into the same medium. Okay, the bouncing back of the light from the reflecting surface is called reflection of light. Same thing, it will take place on concave mirror too. If the light ray incident at the pole, it reflect back. Okay, so these are the 4 ray rules of concave mirror. Now we will discuss about convex mirror. So are you ready? So be ready always. Okay. Chalo. Next. Convex mirror. Convex mirror. Okay. So what is the another name of convex mirror? Another name of convex mirror. So yeah, actually nowadays little busy. So due to that reason I couldn't able to take the classes. But now onwards I'll try to come regularly. Okay. So generally at 9 p.m. Even in the evening time 9 p.m. So daily I will take classes. We need to practice. We need to practice problems also. Problems are there, and theory questions also there. Theory questions as well as problems also will do it. And and test is going on. You can see the community post. In the community post daily I'm posting the test related to content. Related content means you need to write the test. After listening the class, you need to write a test. Okay, so related to board exam questions and expected questions, important questions, important questions. Okay. I'm teaching for CBSE grade 10 physics. So means for grade 10 people. So grade 10. Grade 10 people I'm teaching. So after that I'll come for amazing grade 11 and next wonderful grade 12 students. Okay. Are you teaching live? Yeah. So yes. Newton 4. I'm teaching. Yes, this is a live class. Let's start. Thank you. Thank you so much for encouraging. Thank you so much for watching. Thank you so much for encouraging. Thank you so much for understanding. And thank you so much for supporting. Did you know Telugu? Yeah, of course. Lucifer Gaming. Yes. Even I am taking classes in Telugu also. Another. So, be in different timings. I'll be taking classes. So I already I'm taking classes in Telugu language also. So I'm doing. Okay, so definitely we'll start. Come to the point. Concave mirror rules completed. Now I will discuss about convex mirror. Convex mirror. This is a convex mirror. Okay. So reflection takes place outside. Okay, outer side. I'm taking this a pole, focus and center of curvature. Pole, focus and center of curvature. Oh, thank you so much. I can understand. First one, this is incident ray. So after reflection, light ray is moving through, light ray is passing through focus. And coming to the second one, you can observe here carefully. Light ray is passing through focus. Light ray is passing through focus. Light ray is passing through focus. This is the pole, focus, center of curvature, pole, focus and center of curvature. Light ray is passing through focus. I hope it is very clear to you all. Light ray is passing through focus. This is a focus. After reflection, so it will become parallel to the principal axis and reaching to the infinity point. Okay. Bye. Hi. Welcome to the class. Welcome to the student brand. The world of student brand. This is the pole, focus, center of curvature. Light is passing through center of curvature. Light ray is passing through center of curvature. You can observe here. I'm taking like this. Okay, so it passes through center of curvature. After reflection, it retraces its original path. Light ray is passing through center of curvature. After reflection, it retraces its original path. Coming to the fourth point, I'm taking here. What is this mirror? Convex mirror. So here is the pole, focus, and center of curvature. Light ray is incidenting at the pole. After reflection, okay, so after reflection, the light ray will passes through the same medium. Hi. Harshit Tiwari, hi. Fark, hi. So, okay. These are the 4 ray rules of convex mirror. These are the 4 ray rules of convex mirror. Yeah, so I'm taking classes daily. Definitely I will take. So regularly I will try to be okay. I will try to be regular because due to some work I couldn't able to take classes few days. So otherwise I could take. Definitely I will continue the classes on regular basis. Okay. Yes. So attempt the test. So which I am which I am regularly posting in the community post. Timing generally Sunday I'll be taking continuously like 2-3 classes right from morning 10 I will start at 10, so 10 to 11 until 12, like that it will continue. So yeah, after afternoon time, after 3 o'clock, so from I can understand. I will do that. Username Godfather. Definitely I will do that. Okay, in coming classes. And yes, regarding the classes, so on Sunday it will be 4 classes. So I'll continue all 4 topics, um, like in a sequence. Electricity, after this only electricity chapter. 3 o'clock you can join somewhere. So at 3 o'clock I'll start electricity. And in electricity we need to do problems. At the same time concept also we need to discuss. Definitely I'll start at 3 o'clock. After that 6 and next 9. Like that 4 classes I will take on Sunday. Yeah, definitely I'll do it. I'll do that. Physics only, sir. Yeah, physics only. Okay. And one more thing. And remaining days, right from Monday to Saturday, 9 o'clock. Your explanation is very. Oh, thank you. Thank you so much. Yeah, of course. Viraj Roy. Thank you, sir. Okay. Shall I continue the classes? So I'll continue the classes now. Light reflection and refraction. Light reflection and refraction. Okay, fine. Concave mirror ray rules and convex mirror ray rules completed. Now I will discuss about image formations. Image formations. Image formations are very, very important. So definitely one question can be expected from this concept, especially from this concept one question will be expected in board exam. That to last case, concave mirror last case is very very important. Absolutely you need to practice it, compulsory you have to practice and go to the exam hall, because that much important is. In emergency we do first aid, same thing. If you are going for exam, compulsory you have to prepare like a first aid. Okay, uh, concave mirror last case you have to prepare that topic. Emergency case, even if you don't know anything also from the chapter, that last diagram if you practice and go, at least we can expect, one or two points from that concept, because virtual erect and enlarged image will form, and position may ask, and applications they can ask. So dentist, dentist can observe the teeth teeth of the patient. Dentist can observe the teeth of the patient. And any examples? So let me know. While explaining the concept, I will give the examples. So let's start. First point is, I'm taking the concave mirror. So this is a concave mirror. Pole. It's a pole. Focus and center of curvature. Pole, focus and center of curvature. Object is placed at infinity. Object is placed at infinity. Okay, so first point, object is placed at infinity. Light rays are coming from infinity. After reflection, those light rays are meeting at one point. Okay, on the principal axis, that is focus. Here you can observe like this, and here also. This is a focus. Okay. After reflection, reflector light rays are meeting at one point on the principal axis. So that is focus. Image is forming at focus. Object is at infinity. Image is forming at focus. Nature of the images. Nature of the images. Nature of the images. What is the nature of the image? Real and inverted. Real and inverted and highly diminished. Real, inverted and highly diminished. Yes or no? Real and inverted. Real and inverted. Real and inverted image. So this is the nature. So you need to understand the difference between nature of the image and size of the image. Nature of the image and size of the image. Nature of the image is real and inverted. Size of the image is highly diminished. So you need to understand one thing. Okay. So here nature of the image is real and inverted. Size of the image is highly diminished. Object is placed at infinity. Image is forming at focus. So coming to the second one. This is a concave mirror. Concave mirror. So pole, focus, center of curvature. Center of curvature. Object is placed beyond center of curvature. Object is placed beyond center of curvature. So, how many light rays are required to form the image of that? From the image of the object, minimum 2 light rays are required to form the image of the object. How many light rays? Minimum 2 light rays are required to form the image of the object. So, I am taking one light ray like this. So, after reflection passes through focus. After reflection passes through focus, another light ray I am taking like this. So after reflection, it retraces its original path. Electricity. Okay. Okay, Suresh, I'll do that based on the electricity. There are many concepts we need to do, especially electric current, Ohm's law, resistance and resistivity, and power related and series and parallel related problems we need to do it. It is not for JE, it is for CBSE grade 10 physics. If it is useful for JE, you can listen. Okay. Actually, physics, so right from basics to until the top level we need to learn. So it will be helpful for JE also. and NEET also, and for grade 11, 12, and for everyone, because it's a light chapter. Even from right from 6th standard also, right from 6th to until 12th, even for JE and NEET students also can prepare. Okay. Aroshi, hi. Hi. Okay. Chalo then, come to the point. So object is placed beyond center of curvature. Image is forming between C and F. Object is placed beyond center of curvature. Image is formed between C and F. Okay. Object is placed beyond center of curvature. Beyond center of curvature. Image is forming between C and F. Nature of the image is real and inverted, and size of the image is diminished. Sir, what is the meaning? What is the meaning by diminished? What is the meaning of diminished? Diminished. So what is the meaning of diminished? Diminished is nothing but, so compared to the object, image size is reduced. Compared to the object, image size is reduced. Compared to the object, image size is reduced. So that is known as diminished. Okay. So next one. Oh, yeah, of course. Absolutely. Heads up to you. Working on Sunday too. Thank you, sir. Small image. Yeah, correct, Arashi. Sir, I have a doubt. What is your doubt, Tanish? Raju. Thank you. Okay, done. Coming to the third one. Third one. Hey, Samarth. This is mirror, Samarth, not lens. Okay, Tanish. Definitely. Okay, done. So I'm placing the object at center curvature. I'm placing object at center curvature. So here you can observe object is placed at center of curvature. Image also will form at center of curvature. Okay. So object is placed at C. Image also will form at C. Nature of the image is real and inverted, and the size of the image is same size. Yeah, I'm talking about convex and concave mirror. Correct. So first case only, Tanish. I will teach. Don't worry. I will explain, Samarth. Huh? I'm doing day. Now I'm doing day. Huh? Oh my God. ఓ డైలాగ్ చెప్పాలనిపిస్తుంది. మనకి యాక్చువల్గా ఇది ఆన్లైన్ ప్లాట్ఫామ్ కదా. ఓకే, మన రూల్స్ మనం ఫాలో అవుతున్నాం కదా. సబ్జెక్ట్ చెప్తున్నాం కానీ ఒక డౌట్ చెప్తా. ఒక డైలాగ్ ఉంది, పవర్ఫుల్ డైలాగ్. ఏంటంటే, అనా పోలీసోడే కాదు, పోలీసోడు వేసుకున్న డ్రెస్ కూడా డ్యూటీ చేస్తదంటారు కదా! ఒక డైలాగ్ ఉంది, సినిమాలో డైలాగ్. అదేవిధంగా టీచరే కాదు, టీచర్ వేసుకునే డ్రెస్ కూడా టీచ్ చేస్తది. అది మన మన మోటో. అర్థమైందా? ఇంకో డైలాగ్ గుర్తొస్తుంది. అంటే నార్మల్‌గా మనం ఒక సింక్‌లో ఎళ్ళిపోయామనుకో, దాంట్లో ఎళ్ళిపోతాం. నీ గోలు 10 మైల్స్ అయితే ఎయిమ్ ఫర్ ద 11థ్ మైల్. అంతే. ఓకేనా? సో, కమ్ టు ద పాయింట్. నెక్స్ట్